when doing this problem, you actually have many options. One option we can do is rewriting the problem as something like this, where you raise the entire thing to the eighth. Whoop, excuse me though. Don't forget to give your to -1 to the eighth. This would be one way of doing it. It's not my preferred way, but it's one way of doing it. The reason why it's not my preferred way is now we've got a chain rule inside here, and in fact we have a chain rule inside of a chain rule, and then we have a product rule inside of that. So it gets a little complicated. My preferred way to do it would be doing the problem just as written, where we can see, look, here we have something to the eighth on the outside, and then we have junk, as I like to call it in class, on the inside. So how do you do the derivative of something? Well, this is a chain rule. So you bring your 8 to the front, you leave your junk alone, then subtract 1 from your exponent. So now I use the scratch out technique where I say, okay, I've done the derivative of the to the eighth part. So now what do? Well, I have to do the derivative of the inside. And in here, again, you could rewrite this as x plus 6 to the -1 and do product rule. Or we could use the quotient rule. And the quotient rule is usually preferred. And we just have to remember, it's the low times the derivative of the high minus the high times the derivative of the low, all over the square of what's below. So therefore, when we're doing this, what we're going to say is, okay, it's the low. So the low is x plus 6. So it's x plus 6 times the derivative of the high. Well, the derivative of x plus 1 is 1, minus the high times the derivative of the low. So what's the derivative of x plus 6? That's 1, all over the square of what's below. And now that we've done that, since we've used the quotient rule, we've taken care of the whole quotient, and we're done with the problem. So there you go. There's your answer. Now, if you really wanted to do it the other way, we can. So what we'll do, I'll do it the other way. So what that would look like is y equals x plus 1 to the eighth, excuse me, x plus 1 times x plus 6 to the -1, all to the eighth. And hopefully you can do this any which way. You can either just do chain rule with the 8 on the outside and bring the 8 down to the front and then leave all your stuff on the inside alone. And now that we've done the derivative of the 8, we now start working on the inside, and you see we have a product rule. Or the other option, and this one makes a little more sense to me, is we use a tiny bit of algebra, and what we're going to do is say, okay, we know that since this is this whole thing to the eighth, I can make it x plus 1 to the eighth times x plus 6 to the -8th. So now it's just a little cleaner, I think, and we now are just going to look at this as a product rule. Excuse me, we haven't done a derivative yet though. There we go. And so now when we do our derivative, we're going to say, okay, what's the derivative of the first thing? That's 8 times x plus 1 raised to the 7th. Then do the derivative of the inside, so that's 1. Then leave the other factor alone, so that's x plus 6 raised to the -8th. Then plus, now leave your first factor alone, so that's x plus 1 raised to the 8th, times, now the derivative of the other one, so bring the -8 out to the front. And then when we subtract 1 from -8, that makes -9. Yeah, people always goof that one up. Then the derivative of the inside, so that makes a 1. And there you go. And yes, these two answers are identical. Just this one, if you drop all of your negative exponents down and combine like terms, you'll get the same thing. Okay, I hope that helped.